here's a very interesting lesson, that is operators. In this lesson, we would be learning different types of operators such as arithmetic operators, assignment operators, relational operators, logical operators, and bitwise operators. So let us start our discussion with what are operators. Operators are considered as foundation of any programming language. Thus, we can say the functionality of C programming language or any other programming language is incomplete without the use of operators. We can define operators as symbols that help us to perform scientific, mathematical, and logical computations on operands. Operands is nothing but the data on which we perform operations. Thus, we can say that operators operates on operands. Let us consider an example, C equal to A plus B. So plus is an operator and A and B are operands. Now based on the number of operands the operator will be working on, the operators can be classified as unary operator, binary operator, and ternary operator. Unary operator are the operators which require single operand to perform any action. There are two unary operators, increment, that is plus plus, and decrement operator, that is minus minus. Now comes the binary operator. Binary operators are the operators which require two operands to perform any action. C offers wide range of binary operators. All the arithmetic operators such as addition, subtraction, multiplication, division, modulus are binary operators. Adding to binary operators, all the relational operator, logical operator, bitwise operator as well as assignment operator are the types of binary operator. Now comes the ternary operator. You might have guessed its definition. Yes, ternary operators require three operands to perform any action. There is a single ternary operator called as conditional operator. Let us learn all these operators one by one. Coming to arithmetic operators. An arithmetic operator performs mathematical operations such as addition, subtraction, multiplication, division, modulo, increment, and decrement. You might be knowing most of them. Let us revise them quickly. Addition means it adds two integers. Subtraction means it subtracts one integer from the other. Multiplication and division you might be knowing. Now let us learn more about modulo and increment-decrement operators which are new to us. Modulo operator. Percentage is considered as a modulo operator. It computes the remainder of two numbers, considering first as dividend and second as divisor. As modulo operator is considered as a binary operator, it will require two operands for sure. So the first operand is considered as dividend and the second operand is considered as divisor. Now while dividing the first by second, whatever is the remainder, it is the value of this modulo operator. But it is interesting to know that modular operator can be used with integers only. Now let us see an example. 7 modulo 2. Here 7 is the dividend and 2 is the divisor. When we divide 7 by 2, we get the remainder as 1. So 7 modulo 2 will give us 1. Similarly, 9 is completely divisible by 3. So 9 modulo 3 will give us the remainder 0. Now if we try doing 7.0 modulo 2, here 7.0 is not an integer. It becomes a floating point number. But we have learned that modulo operator operates only on integers. So it will throw an error of invalid operands. Now comes the most interesting concept, increment and decrement operator. Increment operator, that is plus plus, increases the value by 1 and minus minus decreases the value by 1. These operators can be used as prefixes as well as suffixes to an integer variable. Now if, let us say, we have a variable named a whose value is 10. So if plus plus is used as a prefix, that is if we write plus plus a, then the value of a will be incremented by 1 and then it will be returned. Similarly, when plus plus is used as suffix, then first the original value of the variable is written and then it is incremented by 1. Same goes with minus minus. The decrement operator works in similar way except the value is decremented by 1. It can also be used as prefix and suffix to any variable of integer type. Now comes the second type of operators, assignment operators. They are pretty much easy. An assignment operator is used for assigning a value to a variable. The most common assignment operator we know is equal to. Now let us consider two variables a and b. So if we use assignment operator, that is a equal to b, so the value of the b will be assigned to variable a. It is interesting to know that the left hand side of the assignment operator should always be an variable. It cannot be constant, because it makes no sense if we write 5 equal to b and the value of b is 10. So does it really make sense that 5 is equal to 10? No. Similarly, if we write plus equal to, let's say I write a plus equal to b, it means that a equal to a plus b. Similarly, if I write a minus equal to b, it means that a is equals to a minus b. Same goes with multiplication, division and modulo operator too. Now comes the relational operator. The relational operator checks the relationship between two operands. If the relation is true, it returns 1, and if the relation is false, it returns 0. Relational operators are widely used in making decisions in loop. Let's say we have two variables, int a equals to 3 and int b equals to 5. Now let us apply some relational operators onto them. The first relational operator is double equal to, that is equal to. So a equal to b, that is 3 equal to 5. Is 3 equal to 5? No. So it will return false, that is the value 0. Exclamation mark equal to indicates the operator is not equal to. So a is not equal to b, that is 3 is not equal to 5. It is true, so it will return the value 1. Greater than and less than are the common operators that we are knowing. A is greater than b. 3 is greater than 5? No. So it will return false, that is 0. Greater than equal to, less than or equal to are in the same way. Now comes the logical operator. An expression containing logical operators returns either 0 or 1 depending upon whether expression results true or false. If the expression result is true, it will return 1. If the expression result is false, it will return 0. Logical operators are commonly used in decision making. Now let us see the logical operators. The first is logical AND. If we apply logical AND to two expressions or operands, it returns true value only if both of them are true. Whereas for logical OR, it returns true if at least one of the operand or expression is true. The NOT expression. Now it returns true if the operand is false, and it returns false if the operand is true. It just negates the result. Similarly, less than, greater than or equal to, and less than or equal to are also considered as logical operator. Now comes the interesting type, bitwise operator. During computation, mathematical operations such as addition, subtraction, multiplication, division, and so on are converted to bit level, which makes processing faster and saves power. So bitwise operators are used in C programming to perform bit level operations. So the single ampersand represents bitwise AND. The single pipe represents a bitwise OR. This represents bitwise exclusive OR, and this represents bitwise complement. These two left angles represent shift left and two right angles represent shift right. Let us see an example. Now let us apply these bitwise operations with an example. Let us consider two variables a and b as 60 and 13. Let us write their binary representation in the comments. So 60 can be written as shown here and 13 can be written as shown here. Now first operation is bitwise AND. So let us apply it. C equal to A bitwise AND B. The bitwise AND operator copies a bit to the result if it exists in both operands. So now 0 and 0 exist in both operands, so it returns 0. Here 1 and 1 exist in both the operands, so it returns 1. Whereas 1 and 0 will return 0. Now comes bitwise OR. Binary OR operator copies a bit if it exist in either operand. So 1 or 1 will give 0. So 0 or 0 will give 0. Whereas 1 or 0 will give 1 because 1 exists in either of the operator. Then comes the bitwise XOR. Bitwise XOR operator copies the bit if it is a set in one operand but not both. So if both the operands are 0, it will return 0. Both the operands are 1, it will return 0. But if either of them is 1, it will return 1. Now comes the bitwise complement. It is also known as binary ones complement operator. It is unary and it has the effect of flipping the bits. So it just flips the bit. If we do complement of A, that is complement of 60, so 0 gets converted to 1 and 1 gets converted to 0, so this will be the result. Now comes shift left and shift right operator. The binary left shift operator moves the value left by the number of bits specified by the right operand. So let us left shift A by 2. So all these bits will be shifted by 2 places to the left hand side and the result will be this. Converting it to decimal we get 240. Similarly goes with right shift. Now let us try using some of the operators. We will create a new file, operators.c. First include the hash directives, the header file stdio.h, start with the int main. Let us declare two integer variables with value 7 and 2. So int a equals to 7 and the second variable int b equals to 2. Now here we will try using division, modulus, increment and decrement operator. So first let us take one integer variable result and we would do the operation result equal to a divided by b and print the result. Division is %d, that is the result, the value in the variable result. Now let us try doing modulo operator, a mod b. So the result will have the value of the division of a slash b initially, but after we assign a mod b to result, the value gets overwritten. So let us print that value. Printf modulo operator, result is %d, that means the value in the variable result. Now let us do increment operator on a. Let's do a++ and print the value of a. Value of a after incrementing is %d, that is a, the value in the variable a. Then do minus minus, that is a decrement operator, and print its value. Value after decrementing is %d, that is the value in the variable b. Now let us add new line escape sequence in each statement, otherwise the output would clutter up, and save it. Open the terminal, compile it, operators.c, and execute it. So we get the division as 3. Now let us see the result. 7 divided by 2. The quotient is 3 and the remainder is 1. If we divide it completely, then we get 7 by 2 as 3.5. But as our result is integer, so 3.5 gets converted into integer and prints the value as 3. Then the modulo operator, as we divide 7 by 2, we get the remainder 1. So the modulo operator will give the result as 1. Now the value of a is 7. So after incrementing, its value become 8. Same goes with decrementing, the value is decreased from 2 to 1. Now this increment and decrement operator are widely used in loops to update the loop counter. And similarly, we would be using assignment, relational and logical operators in the coming sections wherever required in loops and decision making. So we will get a practice of it over there. Let's have a quick recap. Operators are the symbols that help in performing specific mathematical and logical computations on operands. Operands are nothing but the data on which we process the operations. Operators operates on operands. In the next coming section, we will be learning conditional statements, jump statements, functions, recursion, and patterns.